Hello, hello. We have got another great night of position, velocity, acceleration, and speed. All right, now in calculus, there's a lot of words that imply take the derivative. They're not always going to say straight out in the directions, take the derivative of this. All right, they're going to give you some keywords that mean take the derivative. So get these in your notebook and get them registered in your head. Anytime you want to find a min or a max, all right, that's really telling you take the derivative. Anytime you want to know if something's increasing or decreasing, they're really telling you take the derivative. All right, and those are four huge words we're going to deal with this year. Anytime you see those in the directions, all right, that is implying take the derivative. All right, so let's get those in our notebook and keep that as our main focus tonight. Example 1. A particle travels along the x-axis according to the position function during the time interval 0 to 3, where t is in seconds. At t equals 3, is the particle traveling to the left or to the right? Justify your answer. All right, so here's what's going through my head. I see the words left or right, and that talks about movement. All right, the second I'm talking about movement, I'm thinking velocity. All right, so I need to go get my velocity. So I'm taking the first derivative. So let's see, that's 3t squared minus 10t plus 8. Okay, now I'm not setting it equal to 0 or anything. It specifically says at t equals 3 what's happening. So here's what your AP is looking for full credit. I need to show v of 3 equals, and then I need to evaluate this function. 3 squared minus 10 times 3 plus 8. Okay, and this is again typically non-calculator. So let's just go, that's 9 times 3 is 27, minus 30 plus 8. That gets me a nice 5. Now, what does that tell me is happening? Well, that tells me I got a positive answer, so I can justify the particle is moving to the right, and my justification is not v of t, but specifically v of 3 is greater than 0. Notice I'm not saying it's equal to 5, I'm saying v of 3, specifically at 3, I get a positive number. Part B, this is a fantastic question. When is the particle furthest to the right? What is its position then? All right, the key word that's jumping out of the paper at me and hopefully to you is the word furthest. What does that mean to you? If you are the furthest, can anybody be farther than you? No, you are the absolute furthest. What has to register is they are asking for an absolute, and if they say to the right, that's an absolute max. You are positive, velocity is positive, so you're moving to the right. So let me slow down and say that again. Furthest is going to imply absolute, because nobody can be farther than you, so you are absolutely. Farthest to the right is going to be a max. All right, so what does that tell me? That tells me I need that closed interval test. All right, and on the closed interval test, I used the closed interval as well as any critical points. So to find my critical points, remember I set my derivative, which is velocity, equal to 0. Now, I already had velocity from my previous example, I just have to set it equal to 0. So it was 3t squared minus 10t plus 8. So 3t squared minus 10t plus 8 equals 0. I can hopefully easily factor that. I only have one option for my first term, 3t and t. So I can go with 4 and 2, 2 and 1. Let's see, I'm going to go with a 4 and a 2. That's a negative. Will that work? Let's see. That's negative 6, negative 4 gets me a negative 10. Negative 4 times negative 2 is a positive 8. So that certainly works. I'll tee it up. I get t equals 2. And t equals 4/3. All right, now remember, the word was farthest, so I'm going to treat it like an absolute. And if I scroll back, I think I had a closed interval. Whoops. I did. They told me the closed interval was 0 to 3. So I'm going to treat this like an absolute. I'm going to go with my 0 and 3. Now, I want to slow down and make sure I label my function here. This represents the times it's happening at. T equals 0, t equals 3. I'm going to include 4/3. That's a little more than 1. 3 goes into 4 once, and 2. Now, remember, this is who. Who are you trying to find? You want to know when who is farthest to the right. Read the question again. When is the particle farthest to the right? What are you looking at? Well, if I want to know, picture people standing in line and I want to know who's farthest to the right, I am looking at their position. So let's be very clear that we are plugging these back into position. Okay. So I've taken a moment and rewritten down my position formula so I can carefully substitute those in. I think 0 is probably the easiest to plug in. 0, 0, 0, 0, 1. Let's see. Oh boy, I'm going to have to do some scratch work here. Plugging these in. If I'm going to plug in 3 next, that looks easiest to me. That's going to be 27 minus 5 times 9 is 45, plus 24 plus 1. Hopefully you're checking my math here. I get a 7 there. I'm going to plug 2 in. 2 cubed is 8. Feel free to pause it and do your own math. Let's see. 20, 16, and 1. I get a 5. And then I'm carefully going to plug this annoying 4/3 in. 4/3 cubed, etc. I know that's getting sloppy. You can do your own math there. Let's see. I get a 139 over 27. So now I have to answer the question. When is the particle furthest to the right? All right, so basically I'm just saying which of these is the largest position? When is it farthest to the right? And I'm going to say it's farthest to the right. And let's just read the wording of the question again. It says, when is the particle furthest to the right? So if I say when, I'm asking the time. So I would say when t equals 3. And what is its position? It's positioned at 7. So to answer that question, I would say at t equals 3. And the position is 7. Part C, when is the particle furthest to the left and what is its position? Well, again, the word furthest is the part that's got to jump off at the page. If you are farthest or furthest, nobody can be farther than you. So again, that's an absolute. If I'm talking about to the left, I am looking for an absolute min. So I don't need to redo my math. I just need to look at my table and ask myself, who's the smallest? All right, and looking at that table, I would say, when is the particle furthest to the left? Hopefully you would say at x equals 0. And what is its position? Its position is 1. Question D. At what time does the particle reach its minimum velocity? And then what is the minimum velocity? All right, now, you might have to go back and look at those notes we jotted down when we started. There is a key calculus word here. All right, and that's the part that's got to be jumping off the page. There's actually 2 of them. The first one that jumps out at me is the word minimum. If you want to find a min or a max, that is implying to take the derivative. All right, now it usually tells you who to take the derivative of. You want to find the minimum velocity. So I read this as take the derivative of velocity. All right, and that's how you're going to have to interpret these. So slow down and read it to yourself. The word minimum is implying derivative. Who? Velocity. So if I take the derivative of the velocity, who am I actually going to get? Well, of course, that's acceleration. So taking your derivative of velocity gets you acceleration, and I get 6t minus 10. Set that equal to 0. I've got t equals 10/6, which of course is equal to 5/3. Okay, now, does it say absolute at the moment? No, so I'm going to treat it like a relative. So I'm going to say 5/3. Okay, I'm talking about acceleration. All right. When I plug in somebody bigger, oh, now it had bounds, remember, we could only be between 0 and 3. So I've got to plug somebody in that's between 0 and 5/3. Well, remember, 3 goes into 5 once and a little more, so I know that's bigger than 1. So I could use 1 here. And on this side, I'm going to use 2. If I plug in a 1, 6 times 1 minus 10 is a negative. If I plug in a 2, 6 times 2 is 12 minus 10 is a positive. So what does that tell me? Well, let's read that question again. At what time does the particle reach a min? Well, if this is negative, I went from decreasing to increasing. So I would say I have a relative min at x equals 5/3. Whoops, I probably should say t equals 5/3. The other part says, now what is the minimum velocity? Well, if it happens at 5/3 and they want to know the minimum velocity, all I'm going to do is plug 5/3 into velocity. So I need to find v of 5/3. All right, so I'm just carefully plugging that in. So it was 3t squared, so 5/3 squared, minus 10 times 5/3 plus 8. So that's 25/9 times 3 makes that 25/3 minus 50/3. If I want this to be an 8, that's 24/3, which gets me a total of -1/3. Okay, so I know it happens at 5/3 and the velocity is -1/3. Question E then says, at what time does the particle reach a maximum velocity? All right, so this is really just about slowing down and looking for keywords. Maximum's going to start me off by saying take the derivative. Anytime you want a min or a max, you make a sign chart, you take a derivative. Who do you want to find the derivative of? I want the derivative of velocity. Now, didn't we just do that in the previous problem? So basically, I'm just going to steal that sign chart, and I'm going to look at it, and I'm going to say, okay, did I have a maximum? No, darn, I had a minimum. Well, they're telling you you have a maximum someplace. If it's not happening at 5/3, the max is either happening at 0 or at 3. All right, clearly it's not at 5/3, that was a min, therefore the max must be at one of the endpoints. So I now have to treat it like an absolute. All right, so I have my 0, my 5/3, and my 3. This is my time. Who am I trying to find here? Remember, this is your who. You are trying to find the maximum velocity, so I'm going to put velocity here. That's who I'm looking for. I already know at 5/3 I had a -1 from the previous problem. I'm sorry, a -1/3. And I just need to evaluate v of 0 and v of 3. When I find v of 0, I get 8. When I find v of 3, I get 5. So now I can easily answer the question. At what time does the particle reach its maximum velocity? At t equals 0. And what is the maximum velocity? The velocity at 0 is 8. Letter F. We're really zoning in on these keywords. At what time does the particle reach its maximum acceleration? So again, highlight the key calculus words. Maximum tells you to take a derivative. Who do they want the derivative of? Acceleration. Okay, now I haven't given you a name for that, but it does say take the derivative of acceleration. Well, if a of t, I believe, was 6t minus 10, its derivative, I'm just going to call it a prime of t, is just equal to 6. Okay, and we're going to set that equal to 0, of course. So do I have a critical point? No. But I'm still going to make myself a sign chart. I'm going to call this a prime of t. And basically, I don't have any points to stick on here. That means, well, except the endpoints. Whoops. And that went from 0 to 3. That means you can test anybody you want between 0 and 3. I don't have a critical point, but just pick somebody between there. I think 1 is pretty safe. No matter what I plug into a prime of t, the answer is always 6. Therefore, it's always a positive. So this function is always increasing. Now the question said, at what time does the particle reach its maximum acceleration? Well, it must be happening at an endpoint, okay, because there's no critical points. So I just want to know the acceleration at 0 and at 3. Now you should be able to use some common sense and tell me which one it's happening at. If this function is always increasing, would the maximum be at 0 or would the maximum be at 3? Well, I think common sense would tell you it would be at 3. And I can easily figure out what that is. If I plug 0 into acceleration, I get -10. If I plug 3 into acceleration, I get 8. So I would say my maximum acceleration occurs at t equals 3, and it is 8. Now, I know again, like I didn't give you a name for a prime of t. Those of you that take physics, I believe after acceleration comes jerk, would be the name of that. Lastly, it says as t equals 1, is the speed of the particle increasing or decreasing? Justify your answer. Well, we talked about speed the other day, and to see if speed is increasing or decreasing, I have to compare both velocity and acceleration. So I need to find v of 1 and a of 1. Alright, so just use your two functions, plug in 1 to velocity, plug in 1 to acceleration. I get a 1 for velocity and negative 4 for acceleration. And because I got different signs, I would say that the speed is decreasing because not v of t, v of 1 and a of 1 have different signs. Here's a really common AP question. Two particles travel along the x-axis. The position of particle A is given by a of t equals 8 cosine pi over 4t, and the position of particle B is given by b of t equals the sine of pi over 6t. At what time are the particles traveling in the same direction? Alright, so again, I'm looking for the key calculus word, and to me what jumps off the page is the word direction. Anytime I'm talking about movement, left, right, up, down, direction, I'm looking at their velocity. Alright, and hopefully that's what you're starting to pick up on. So I have to compare the velocity of these two functions. Now let me add in one other piece of information here. Let's say this is given on the closed interval 0 to 10. Otherwise we'd be doing this all night long. So 0 to 10 is our closed interval. Alright, so my first goal is to go get the velocity of each function. And notice that I was given the word position. Alright, take note of who you start with. So if I want their velocities, I need to find each of their derivatives. So I'm going to start with a prime of t. Read it out loud. 8 cosine of pi over 4t. There's my chain rule. So I get 8's a coefficient, leave it alone. Negative sine, keep the inside, times the derivative of the inside. And I want to set that bad boy equal to 0. Alright, now here's where our trig skills come in. Let's take our time on this. This is something you're going to have to be able to do quite frequently. As I clean this up, I can multiply this term and this term, so that gets me in the negative. I get a negative 2 pi sine of pi over 4t. And I'm setting that equal to 0. Now the first thing I say to myself is, okay, I can easily divide out my negative 2 pi. Alright, that's just some silly constant, and that's gone. So the question really says, when is the sine of pi over 4t equal to 0? Alright, now I know some of you can guess and check and you can come up with some numbers that work. That's not what I want you to do. I want you to be able to solve these equations pretty easily. So here's my little trick. I completely ignore what's in those parentheses. And I basically ask myself, when does sine equal 0? And I'm going to get several answers. Okay, picture your sine curve. When does sine equal 0? I can name 3 times. I'm going to say at 0, at pi, and at 2 pi. Alright, so now watch what I do. I take the junk that was in there, that was my pi over 4t, and I'm going to set it equal to each value I've got. So sine equals 0 at 0. I'm going to take that pi over 4t, sine equals 0 at pi. I'm going to take that pi over 4t and say one more time, again at 2 pi. Alright, so let me slow down for those of you that didn't get it. I ignored what's in here. I just said, when does sine equal 0? Got my 3 numbers, there they are, 0, pi, and 2 pi. And now I went back and I took whatever was in those parentheses and set them equal. Now I'll solve. I'll just simply multiply by 4 over pi, 4 over pi, 0 times anything is 0. 4 over pi, 4 over pi, pi's cancel, t equals 4. 4 over pi, 4 over pi, pi's cancel, I get t equals 8. Alright, so this happens 3 times. Now, let's make our sine chart. Alright, please stop calling it a number line for those of you that still do it. It's called a sine chart. We had closed intervals from 0 to 10. Alright, I've got to use my critical point of 4 and my critical point of 8. And this represents a prime of t, and this will describe a. Alright, now I've got to carefully plug these numbers into my derivative. Now remember, I don't really care what I get, I just care whether I get a positive or a negative. So watch how easy this is. I'm going to plug a 2 in here. So I get pi over 4 times 2 becomes pi over 2. What is the sign of pi over 2? Picture your curve, that's a 1. And 1 times negative 2 pi is a negative, which tells me the particle is moving to the left. In between 4 and 8, I'm going to use a 5. Okay, the sign of 5 pi over 4 puts me, 5 times 45 puts me in the third quadrant where sign is positive. And a positive times a negative 2 pi, oops, I think I just got ahead of myself. The third quadrant sign is negative, and a negative times a negative is a positive. So I'm moving to the right. Now I'll plug in a 9. I get 9 pi over 4. Now clearly that's not a number I know, so I'm going to take 45 times 9. 9 times 5 is 45. Carry the 4. That gets me a 405. Subtract my 360. That puts me in the first quadrant where sign is positive. Times a negative gets me a negative. So I'm moving to the left. Now I have to do the exact same thing for my B term. And I'm going to leave that one up to you. So I'm going to go rewrite down my B. And I'm going to speed things up here. Hopefully you can do this quickly on your own. We'll take that derivative. I get b prime of t equals cosine of pi over 6t times pi over 6. We want to set that equal to 0. Remember, I'm going to divide out the pi over 6, so I get the cosine of pi over 6t equals 0. All right, now try this one on your own. You're going to have to be able to solve these. Remember, kill this term, come up with some solutions, and set that equal to pi over 6t. Pause it, see what you get. I did my math pretty quickly. Hopefully I did it right. I said cosine equals 0 at pi over 2 and at 3 pi over 2, multiplied by my reciprocal. Killed those pi's, got a 3. Killed those pi's, got 18 over 2, or 9. Now I'll make the same sign chart, but for b prime of t. Remember, it starts at 0, ends at 10. I've got to test 3 and 9. So take your time, plug some numbers in, and see what signs you get for your sign chart. Pause it, see what you get. So you can see the numbers I plugged in, hopefully. I plugged in a 2 here, a 5 here, moving to the right and to the left. Now the question says, when are they traveling in opposite directions? So you don't need to rewrite them. I rewrote mine so I can see them together. And let's just start off. From 0 to 3, they are traveling in opposite directions. 0 to 3, this guy's positive and this guy's negative. From, again, I would say from 4 to 8. Okay, so I'm just looking in this section. From 4 to 8, this guy's positive, and 4 and 8, this guy's negative. And then again from, I would say, 9 to 10. From 9 to 10, this guy's negative, and this guy's positive. So I would say they're traveling in opposite directions during that time. They would be traveling in the same directions. When would they be the same? I would say they're both from 3 to 4, this guy's negative, and this guy's negative. And let's see, from 8 to 9, this guy's negative and this guy's negative. They are traveling in the same direction because they have the same signs. And again, they have different signs. And I really shouldn't say they. A prime of t and b prime of t have different signs. In here, a prime of t and b prime of t have the same signs. Well, that's all I've got for you tonight. Hopefully you've taken great notes, and we'll see you tomorrow.